In this video, we're going to look at section 4.2. So this goes along very closely with 4.1 on apportionment. So remember in 4.1, what we did is we took seats, whether they were seats in government or a similar situation, and we used population to discover how many seats each state deserves. So once we've done that, we do have to find a way to split these up since we can't give away partial seats. So this method was proposed by Alexander Hamilton in 1792 as a way to apportion the seats in the U.S. House of Representatives. His method was never actually used, but it's pretty easy to follow and understand, so it's a good one for us to study. There are a lot of apportionment methods. Probably you could find 20 or 30 if you research them, but we're just going to learn one just to kind of give us an idea how this works. So first, the steps for Hamilton's method. You're going to start, we're going to find each state's standard quota. And this is what we were doing in the previous section. And I also want to put here, it may be given in the problem, so we may get to skip this step. All right, so this is going to give us an exact amount, but we know that the seats are indivisible. So we have to figure out how to get those partial seats and get them divided up correctly. So what we're going to do in step 2 is we're going to round each quota down to its lower quota. That's just a fancy way of saying round down. And use this initially as the state's apportion. All right, so if we round everything down, we are going to have some extra seats left over. So we have to figure out how to split those up. So we are going to give the surplus seats one at a time to the states with the biggest residual, and I'm going to put in parentheses biggest decimal part. Okay, so whichever one has the biggest decimal part, we are going to give that seat away first. Then we are going to repeat until no seats are left. All right, so let's look at an example of how we might do this. So here is an example that's been given to us. And here's the quota. So they've already told us how many seats each state deserves. If you add all of these together, you will see 250. And this is really important because that is the number of seats we have to give away. Now I want you to look at the lower quota right here and the residue. So the residue is what we're calling the leftover part, or the decimal part, and we'll see it down here. So notice what we did is we took A's quota of 32.92. We put the 32 here, we put the 0.92 here. So we're basically splitting the whole number in the decimal part. So we're rounding down to do the number of seats, and then we're putting all the leftover pieces down here. Now if you add all of these together, you will get 246. So if we stayed exactly like this, we would have 4 extra seats. So we've got 4 to give away to get back up to the 250. So we're going to start by figuring out who has the biggest decimal. So if we look across, it looks like this one is the biggest. So that one's going to be first. So what that means is we're going to give state A an extra seat. So instead of 32, we're going to bump them up to 33. Now remember, we have 4 seats to give away, so we have to do this 3 more times. So if we look at what's left, the biggest decimal is 0.82, so they're second. So we're going to give them an extra seat as well. They're going to bump up from 41 to 42. All right, if we look at what's left, it looks like 0.76. So that'll be the third. So that's going to bump them from 19 to 20. Okay, so we've given 3 seats away. We still have 1 more to go. So if we looked at these are really close. 0.72 is a little bigger than 0.70. So we'll give them the 4th seat. So that gives them an extra seat, so they're 139. Now the ones that didn't get an extra seat, we still have to bring their numbers down. So there's a 3, they didn't get an extra, there's a 13. So we want to make sure that when we get this, we add it all together. So 33, 139, 3, 42, 13, and 20. And it should add up to be 250. So this is really your final answer right here. Let me do this in a different color since I've already used that color. This gives us our apportionment. Now this seems really logical and easy, so the question is, why was it never used in the government? The problem deals with population size. So for example, we gave the last seat to the 0.72. Notice state E was 0.70, so they were really close, but they didn't get an extra seat. So this residue for state E represents 5% of its population. It's a very small state. But the one that got the extra seat was B, and the residue was only 0.5% of its population. So the problem with Hamilton's method is it does give an unfair advantage to large states, and a good apportionment method really shouldn't do that. So that's why this method was never used, but it's a really easy one to follow.